Okay, so this is the section 4.4 where we're factoring by greatest common factor. And on these examples, I'm going to look at some trinomials, but I first wanted to hit just a couple reminders on here on how we're going to factor. Again, we're trying to find what's the biggest number that goes into every single term. Okay, and on these ones, they're going to have 3 terms, not 2 like the previous ones. And then do all the terms have the same variable? If they don't, you don't take out a variable. If they do, you have to take out a variable. So remember, just using the greatest common factor, you're going to divide all the numbers and then subtract the exponents to figure out what's left. Again, we're using the distributive property backwards here. So remember, on the distributive property, we're multiplying. So if I want to go backwards, I got to use division. Okay. All right, so first example here. Let's take a look here at this one. So notice this one has 3 terms. That's why they call it a trinomial. Okay, so what I need to do is I need to find the biggest number that goes into 21, 35, and 28. All 3 of them in this case. Okay, well that number happens to be the number 7. Okay, now the other thing that I need to figure out is that has an H, that has an H, and that has an H. Now, what's the lowest number of H's possible? Well, in this case, it's 1. So I'm going to take out at least 1 H. Take away 1 H from everybody. Okay? So that's how I'm determining what I'm taking out. Now, again, I divide 21 divided by 7 is 3. Okay? I have 3 H's here. I want to take 1 H away, which means how many H's are left over? Well, that means there's 2 H's left over. Okay, then I'm going to go positive 35 divided by 7, which is positive 5. And I have 2 H's. Taking one of those H's away, which leaves me with 1 H. And then negative 28 divided by 7 is negative 4. And then the H's, I have 1 H. I took that H away, so I don't have an H anymore. And now you have factored your first trinomial. Okay? So trinomials are really not any different than binomials in the other than the fact that you're dividing 3 times now. Okay, this example's not in your notes. You're going to want to jot this one down here. There's a reason I put this one in there. Something that you might notice is a little bit different about this one, and you'll see examples like this, is that every single term is negative. Well, if every single term is negative, that means that's something that they have in common, so I have to take it out. So as I look at this, what's the biggest number that goes into 8, 32, and 16? Well, that happens to be the number 8, but they all have a negative, so I'm going to take out a negative 8. Okay, it's only if they all have negatives. Then we got 4 x's here, 3 x's here, and 2 x's here. They all have x's. What's the lowest amount of x's that they have? Well, that happens to be the 2 of them. So I'm going to take out 2 x's from everything. Okay, so again, negative 8 divided by negative 8 is positive 1. And I don't have to write this. You can write it if you want to. So I'll put a 1 there just for now. So I had 4 x's here. I'm taking 2 of those x's away, which means I still have 2 left. Then I'm taking negative 32, dividing by negative 8, which gives me positive 4. I have 3 x's here, taking 2 of them away, which means I only have 1 left. And then finally, negative 16 divided by negative 8 is positive 2. And then I had 2 x's here. I took those 2 x's away, so I don't have any x's anymore. So my final simplification here is I've got negative 8 x squared times the quantity 1x squared plus 4x plus 2. Alright, so now you should be able to complete page 2 of your class kick problems here for 4.4 factoring by greatest common factor.